Hello everybody. Today we're going to be talking about graphing quadratic equations. So make sure that you take notes and answer the survey questions at the end. Graphing quadratics. So to start off, a quadratic function is described by an equation with the form ax squared plus bx plus c, where a is anything else but 0. Ax squared is called the quadratic term. Now, when a is less than 1, the parabola opens down. So if it's negative, it opens down. When a is greater than 1, so if it's positive, the parabola opens up. Bx is called the linear term. C is the constant term. Okay? The graph of a function is called a parabola. All parabolas have an axis of symmetry. So the axis of symmetry is pretty much where if you were able to fold a parabola in half, along its axis of symmetry, it would perfectly line up and match up on both sides. So when you talk about like people have symmetry of their face, if you were able to fold their face down the middle, it would match up perfectly on both sides, and there wouldn't be any differences. So it's the same kind of thing. The point at which the axis of symmetry intersects a parabola is called the vertex. Okay, so here's a diagram of a parabola, which a lot of you have seen before. So down here at the bottom we have our vertex. Okay, it's a very basically the point of our parabola, even though a parabola is round. The line of symmetry, or the axis of symmetry, goes through the vertex. Okay, we have this point down here, the y-intercept, and then we have these 2 points right here, which are the x-intercepts. Okay, and we'll talk about those different pieces later, what those actually mean and what we use them for. So finding the vertex, which is a pretty big deal when we're graphing a quadratic. To find the vertex, we use the formula x equals negative b over 2a. This tells us the equation for axis of symmetry and the x-coordinate for the vertex. So to find the y, we plug in the x-coordinate back into the original equation, and that'll tell us what our y is. And this will all start to make sense when we look at an example. To find the x-intercepts, we factor the quadratic equation and set y equal to 0, and we solve for x, which is what we did most recently in class. Your solutions are going to be your x-intercepts. To find the y-intercept, set x equal to 0 and solve for y. Reflect the second point over the axis of symmetry to match the y-intercept. This is really easy because generally on a quadratic equation, when we plug in 0 for x, we're going to end up getting whatever's just left as our constant term. So generally, our y-intercept is simply our constant term. So once you have all these points, you should have enough to make a complete graph. So let's see what that looks like. So we're going to graph this equation, y equals x squared plus 2x minus 3. So first thing that we should do is I'm going to label that I have a is equal to 1, b is equal to 2, and c is equal to negative 3. Okay, so first step, we need to find the axis of symmetry in the vertex. So we're going to start doing that by using our formula. X equals negative b over 2a. Okay, so we're going to plug in these values of 2 and 1 and for b and a. So we get x equals negative 2 over 2 times 1. So that gives us negative 2 over 2, which equals negative 1. So now to find my y-coordinate from our vertex, I'm going to take that negative 1 and I'm going to plug it back into my original equation for x and solve for y. So I get y equals negative 1 squared plus 2 times negative 1 minus 3. So simplify this down, we get negative 1 squared is 1, 2 times negative 1 is minus 2, minus 3. 1 minus 2 is negative 1, minus 3 equals negative 4. So our vertex is at negative 1 for our x-coordinate here, and negative 4 for the y. Okay. Next step, we're going to find the x-intercepts. And we talked about most recently in class how to do this. First we factor, so we're going to factor out our x squared plus 2x minus 3, so we need two numbers that multiply to give me negative 3, but add to give me 2. And those two numbers are going to be negative 1 and a positive 3. Okay, and like we talked about, we're going to set this equal to 0. So, and by the zero product property, that means that x minus 1 equals 0, and x plus 3 equals 0. Let's solve both for x, so we get x equals 1 and x equals -3. And those are my x-intercepts. Last step, we're going to find the y-intercept. And this is simple. All I'm going to do is plug in 0 for x and solve for y. So I get y equals 0 squared plus 2 times 0 minus 3. And this is nice because these two go away. 0 squared is 0. 2 times 0 is 0. So we get y equals -3. And so that is my y-intercept. So now let's see what this looks like when we put it on a graph. Okay, now as a reminder of our information, axis of symmetry was x equals -1. My vertex was -1, -4. My x-intercepts were x equals 1 and x equals -3. My y-intercept is y equals -3. So let's put this on this coordinate graph. Now I apologize, this is going to look kind of sloppy. I am writing on a computer screen, so bear with me. Okay, so first let's draw axis of symmetry. So x equals -1 is a line going vertically through my point -1 on my graph here. Let's do this in a brighter color. Let's try red. Okay, we do this a dotted line here. Okay, so there's my axis of symmetry. My vertex lies on that. It's going to be at -1, -4. So over to -1, down to -4. Okay. X-intercepts are x equals 1 and x equals -3. So on the x-axis, we get x equals 1 and x equals -3. Okay. And the y-intercept, y equals -3. So on the y-axis, we get -3. And then just for added measure, we're going to go ahead and reflect that over my axis of symmetry. So remember I talked about axis of symmetry. If we folded it, our parabola over our axis of symmetry, it should match up perfectly. So since our y-intercept is 1 away, we're going to put another one in the same y spot, 1 away on the other side. So then when I connect these lines, hopefully yours looks better than mine. It makes a nice parabola. And there you go. Here are your survey questions. Make sure to answer these on your notes. Have any questions ready when you come to class? See you then.